Hello everyone. So today let's learn about prototype design pattern. So this is also one of the creational design patterns which revolve around how the objects are created. According to this pattern, we can create new objects by copying or cloning existing objects rather than creating new objects from scratch. So what could be the difference between creating from scratch and cloning? So the main difference between creating objects from scratch and cloning is that when we create objects from scratch, it involves invoking a constructor and executing the constructor to set up its initial state. It also involves initializing the object state. But whereas cloning involves copying an existing object's state to create a new object. So in this example, we have a static initialization block. Okay. We also have an instance initialization block, and then we have a constructor. Okay. We also have an instance variable, and we have its relevant getters and setters. And this class implements the clonable interface, and it is overriding the clone method. So wherein we will return the clone of this class. So now let us see what we exactly mean by creating from scratch and cloning. Okay. So we will take a client class here and we will write a main method in this. Now first let us create the main class, which is not a clone obviously. So we will have this main class. Okay. So now we will execute this and see what happens. So now when we execute this, you can see that first the static initialization block was executed, and then the instance initialization block, and then if there are any super calls, super class constructor calls, that will happen, and then it will be the constructor call, so the subclass constructor. Okay, so in this way the object is created and the memory is allocated. Okay, so now if you see the instance variable, we are not printing it here. So let us print that one as well. So we will print the instance variable to make it more clear. Get the instance variable. Okay, we will run this class again. So as you can see, the static initialization block, instance initialization block, the constructor, and then the instance variable was assigned. So this is the entire process of creating a class from scratch. Okay, so now let us create the clone and see what will happen. So we have taken this class and let's name this variable as clone. And instead of creating a new object, so now what we will do is we will call the clone method. So now let us see what will happen. So now when I run this, as you can see, these were initialized, set up or constructed only once. So this is the first time when the instance is created. But when we clone, the constructors, the initialization blocks, the setting up of the instance variables, so all this did not happen. So this is the difference between creating an object, an actual object, and then cloning the object. So when we clone the object, it doesn't do all of this. So it just takes the object's state from memory and then creates a copy of that object. So it doesn't go through the process of initialization blocks, constructors, super constructors, and all of that. Let us also see if the instance variable is set or not for this clone. Okay, so we will print the instance variable here. Okay, so the instance variable line should be coming twice down here. Okay, we have just added the println statement. So as you can see, this was the main object which got created, and then we are printing the instance variable which was assigned in the clone. So the value is directly copied, so it is not executed from the constructor. So this is the main difference between creating object from the scratch and cloning. That's all good, but how do we implement? The prototype pattern is implemented by creating a prototype interface or an abstract class which defines the methods that all prototypes must implement. Then we create concrete prototype classes which implement these methods to create new instances of the class. So now let us see the prototype pattern with some very good examples. So suppose we have a paint application where we have different shapes, rectangle, circle and all such. So every time the user clicks on the shape, we don't want to create the entire object again. So we want to just, from the prototype, we just want to clone the properties and then use that shape to create it. Okay, so and as we discussed, for the prototype pattern, we will have either an interface or an abstract class that is either extending or implementing the clonable interface. So here the shape is our prototype. So this is our prototype, and with this prototype we can create the other shapes as well. Okay, so in the prototype pattern we will have a prototype which is an interface or an abstract class which either extends or implements the clonable interface. So here this is our prototype which has some set methods, like the clone method is the important one, which should return this shape, the prototype itself. And then we have some three setters here to set the size, color and style of that shape. And then we have a method to actually draw that shape. So this is our prototype interface. Okay, so now we have a rectangle class which is implementing this shape. Okay, so it has all those three properties, color, size and style, and we are setting this in this constructor, and we have the relevant setters here. Okay, we don't need the getters, so we did not add the getters. And then we have the draw method. Here we are just printing that we are drawing a rectangle with so and so color, size and style. And then this is the main part where we have to override the clone method and we have to return the prototype. Okay, so this is the actual part which does the cloning. So we will return the prototype by calling super.clone. Okay, so this is one of the shapes. We can have other shapes, circles, squares, whatever we would like to have. And then we have suppose the main paint application where we will use this prototype to create our clones. So first let us create the prototype. Let's name it some shape prototype or a rectangle prototype. Let us name it rectangle prototype. So that is an interface, we cannot create an instance of it, right? Yeah, so we will set the color, suppose red, the size of it around 10 and some style. So let us make it a dotted style. Okay, so this is the prototype which we have. Okay, so now let us create now another rectangle which would be the clone of this prototype. Okay, so this is suppose rectangle 1. So here what we will do is we will take this prototype and clone it. So polymorphism here, so this has to be shaped because in our clone we will return the prototype, right? So this is the prototype that we are returning. And then let us draw this rectangle. Okay, let us see what happens here, what it draws. As you can see, it is drawing a rectangle with color red, size 10 and style dotted. Now we can also change the variables, right? Once we have cloned it, we can change it as per our wish. So let us set the color maybe blue, and let us see now if it draws the blue rectangle. Okay, so now it's drawing a rectangle with color blue, size 10 and style dotted. So we can try creating, so like in this way we can create many prototypes of this rectangle instead of going through the creation process once again. Okay, so here we are not invoking any constructor, we are just cloning the shape and we can set it as per our requirement. So here suppose let us set the size as 5, we want a thin rectangle and let us draw this. Okay, so now when we run this application, so here we are drawing a rectangle with color red, size 5 and style as dotted. So in this way we can use the prototype pattern when we do not want to go through the object creation process once again. We can just create it once and then clone it multiple times. So what's deep copy and shallow copy? Okay, so when we are cloning, what happens is by default, it will do only the shallow copy. So what do you mean by shallow copy? Suppose if we have a class which is clonable and it is having some variable that is pointing to some other class. Okay, so that is not just a string or integer or anything. That is an object which is pointing to another object. So in shallow copy, what happens is it will create the copy, but instead of creating the new object of that class which is the old one pointing to, it will just copy the memory address of it. So we will see that with this example. So here we have a person class that is implementing clonable. Okay, so this is our prototype class. So it has two variables, name, age, and then it also has address. Okay, so address is another class with its own attributes. It has some address lines, pin code, city and state. Okay, so now in shallow copy what happens is, so when we create this object, so here what would be there, it would have the memory location of this address object, right? This address variable would have the memory location of the object whatever was created. Okay, so that memory address will directly get copied into the clone instead of creating a new address. So that is called shallow copy. And in deep copy, what would happen is the new address would get created again. So there is another address object created first, and then the memory of that is replaced in this variable. So that is a deep copy. Okay. So here this person class has its own getters and setters for all the attributes, and then we have overridden the clone method. Okay, we are returning this prototype person which we have, and we are doing this super.clone. And instead of try catch, we have just written the throws clause, clone not supported exception, instead of the try catch block. And then we have the address. Okay, this is a plain class which is having its attributes constructor, getters and setters. Okay, so now let us see with an example what a shallow copy does. So here first we have created an address object. Okay, so this is just one object which we created, and then we have created a person object. So this is the first object which we have created, which actually has gone through the constructor and getters and setters, all of the construction process of the object. And then the person 2, we have just cloned it. Okay, so here it does only the shallow copy. We will see how. Okay, so here in the person 2, we are just setting the name, setting the age, and address I will not show it now. Okay, we will see it once we run it once. And then we are just printing some details of both the person 1 and person 2. So quickly let us run this. So as you can see, so this is the first person and this is the second person with the details. Okay, we have changed the name and age here, and that also got updated in the cloned object. So now let us print this. Okay, we are changing the address of the second person to some other state, and what happens now? Okay, let me run this. Okay, so now as you can see, it has changed the address in both the places, because what happened is when we cloned, there was no new address object created. So it is the same old address object with both the main one and also the cloned person. So both of these were pointing to the same address object. That is why when we changed the address for the clone object, so it also changed the address of the actual object as well. So which is a big no-no, right? It should not happen in that way. So to avoid this, what we have to do? Okay, so we have to do the deep copy, obviously. So how do we do that? So here what we will do is, even this class address, we will have to implement the clonable interface, and we will have to override the clone method. Okay, so we will override that method. We will return the address, we will name it as a clone method, and then we will return the address, right? Okay, and we will just use the throws declaration here instead of the try catch, and it doesn't end here. Okay, so we will have to call this clone method whenever we are creating a clone of person as well, right? Because we are creating a clone of person, so here we need to use this clone of the address. So now what I will do is, this clone person dot address equal to address dot clone, right? So now what happens is, the address will also get cloned, and that will get again assigned to the cloned person object which we have. So now let us run this again and see what would happen. Okay, so now as you can see, the first person was not changed, the address of the first person was not changed, and when we changed the address of the second person, that got changed as expected. Because when we created the clone of the second, when we created the clone for person2 variable here, so it ran the clone method here, and then it also created the clone of address as well. So instead of just copying the memory address of the old object of the actual object into this address variable, it has created a clone of the address, a new object, and then that new memory address it has assigned to address. So in this way we have here now address clone as well as the person clone. So this is the main shallow and deep copy. Okay, when do we actually use this pattern? So we can use this to create multiple objects with the same state, okay, as the existing object which is already there, without having to go through the entire process of creating object from the scratch, as we have seen already. And when we can also use it when the process of creating an object is expensive, like suppose we are loading class from somewhere, like from a database, or it is a time consuming process to create the object if you have a lengthy constructor or many fields to instantiate. So in that scenario also we can use the prototype pattern. Okay, what could be the limitations of this pattern? So as you have seen, not all the objects can be cloned, because they might have some complex structures, some complex behavior, and some objects may not be able to be cloned correctly if they have like references to other objects, and those other objects might not be in our hand, like we cannot go and directly implement clonable interface there, or if they have a complex state. So in that scenarios, we will not be able to clone the objects, right? So that is one limitation. And also sometimes we might create the clone, but it could have some unexpected or some unintended behavior. So whenever we are using this pattern, whenever we are cloning any object, we have to use it with utmost care. I hope you liked this video, and if you did, do hit the like button, please subscribe to my channel and hit the bell icon to get the notifications for the next videos. Thanks for watching.